Hi, I'm Tyshawn Moore. This is my CSC 318 final project, Hydra AI, an offline knowledge assistant. I built it solo and took it through the full software development lifecycle. The problem I wanted to solve is simple. There are plenty of situations where you need a reliable answer but you don't have internet, or you don't want your questions leaving the machine. A workshop floor, a field site, a lockdown computer. Cloud chat tools don't work in those spots, and they send your data to a server. So the gap is a reference tool that's private, local, and predictable. Hydra AI fills that gap. It answers your questions from a local knowledge pack completely offline. It's meant to run right off a USB drive with no extra software to install. And the part I care about most, when it isn't confident in an answer, it tells you instead of making something up. There are 4 core features. Ask, which matches your question to the best answer and falls back safely when it's unsure. Search, to look up what's in the pack by keyword. History, which saves every exchange to disk so you can review it. And session stats, so you can see how many questions it actually answered. It's built in Python, and on purpose, it has no third-party runtime dependencies, just the standard library. Testing is with PyTest, and the whole thing is version controlled in Git with small, incremental commits. The architecture is layered. The CLI is the presentation layer. The assistant is the service layer that coordinates things. The knowledge pack is the domain layer that does the matching, and the history store handles persistence. Each layer only talks to the one below it. The key decision here is dependency injection. Nothing builds its own dependencies. That's what makes the whole thing testable, and you'll see why on the testing slide. Here's the class view. 4 classes across those 4 layers. The CLI calls the assistant, and the assistant uses the knowledge pack and the history store. Clean, one job each. This is what happens on a single ask command. The question flows from the user down through the CLI and the assistant to the knowledge pack for the match, then over to the history store to be saved, and the answer comes back up to the screen. Solid arrows are calls, dashed ones are returns. Switch to a terminal in the project folder. Let me show it running. Run python main.py. Ask, how do I install Hydra? It returns the answer from the pack. Find history arrow shows the entries that mention history. Ask, what is the weather today arrow? This isn't in the pack, so watch. It gives the safe fallback instead of guessing. That's the behavior I wanted. Stats arrow shows what it answered this session. Testing follows the pyramid. Unit tests hit the matching logic in isolation with the edge cases, empty input, no match, the fallback. Integration tests run the assistant with a real pack and a real history file. System tests drive the whole app through the CLI. 16 tests, all passing 82% coverage. Process-wise, I used the unified process phases, inception through transition with agile habits inside them. Build a layer, test it, commit, repeat. If you look at the Git log, it reads as small working steps, not one giant commit at the end. The biggest challenge wasn't a bug, it was structure. Early on, one function did too much, and every test I wrote had to drag the rest along. Splitting it into layers fixed that. The lesson I'm keeping is that hard to test usually means badly structured, and that's worth listening to. So Hydra AI is private, offline, predictable, and fully tested, and it went through the whole life cycle. Down the road, I'd add richer packs and smarter matching, and the layered design means I could put a GUI on top without touching the core. Thanks for watching. Happy to take questions.